It is theoretically possible for a three-phase service with a large load imbalance between phases to show up as a very low power factor. Power factor is a measure of the phase difference between the voltage and current waveforms. In a balanced three-phase system, the voltage and current waveforms are in phase, and the power factor is 1.0. If the load imbalance is large, the voltage and current waveforms will be out of phase, and the power factor will be less than 1.0. The severity of the power factor reduction will depend on the magnitude of the load imbalance. A small load imbalance will only cause a small reduction in power factor, while a large load imbalance can cause a significant reduction in power factor. The power factor can be measured using a variety of methods. Firstly, a voltmeter and ammeter method involves measuring the voltage and current on each phase and then calculating the power factor using the formula power factor equals real power divided by apparent power. Real power is the average power consumed by the load. Apparent power is the product of the voltage and current. Secondly, a power factor meter measures the power factor directly. It is important to note that the power factor measurement method can affect the accuracy of the result. For example, a voltmeter and ammeter can only measure the average power factor, while a power factor meter can measure the instantaneous power factor. The instantaneous power factor can vary over time, so the average power factor may not be a good representation of the overall power factor. In the case of the three-phase service with a large load imbalance, it is possible that the power factor measurement method was not accurate. For example, if a voltmeter and ammeter were used, the average power factor may not have been a good representation of the overall power factor.